Now I will hand over the stage to Mr. Uday for his deliberation lecture.
हेलो यस गुड मॉर्निंग रादर गुड आफ्टरनून। आप सब लोग बहुत अलग अलग जगह से आए हैं। एक बेटी है यहाँ पे, उसने मुझे बताया कि वो विरार से आई है। तो विरार से शी स्टार्टेड एट अराउंड 9:30 एंड शी हैज़ रीच्ड हियर। सो दिस मच पेशेंट वेटिंग यू हैव बीन डूइंग फॉर some about 45 minutes of lecture. It is a wonderful thing, and I thank Nehru Science Center to allow me to come here and talk to you. So now the spectrum of students and the audience in altogether is such that I don't know where exactly I'm going to pace my content, but I'll try to do my best and try to satisfy to a certain extent to every group. I hope I am successful in this today. So the topic is atom, a clean source of sustainable energy. तो इसमें छोटे बच्चे सोचेंगे कि ये सस्टेनेबल एनर्जी क्या है, वो सब छोड़ दो। एटम सबको पता होगा, राइट? एटम, व्हाट इज एटम? एटम इज द स्मॉलेस्ट, व्हाट इज स्मॉलेस्ट पार्ट ऑफ व्हाट, राइट? सो इफ देयर इज अ गोल्ड material which is made up of gold, material which is made up of silver, whether the smallest part will be same or different, what do you think? I am so sorry. Now you have to say that the from the atom level the material is different. Okay, now once we have arrived that every atom is different, okay, it is very small but it is different. But can we try to imagine what is the size of an atom? I'll give you one interesting example. If there is a glass full of water, right, around 200 ml of water, it will contain how many atoms or molecules? We'll talk about molecules since it is water. What is the chemical formula of water? H2O, right? So I will tell you, if it is 180 grams of water in a glass, how many molecules are expected to be there in that? You know? Yes? You have to tell me in 10 power how much? You are away by 10 power 9, factor of 10 power 9. So it is 10 power 23. Okay? In fact, 10 power 24 if we are saying 180. Have you heard of Avogadro number? Anybody? If not, no problem. 18 grams will have 6.02 into 10 power 23 atoms. So this number is a little bit we have never imagined. So I can tell you that the number of atoms in a glass full of water are equivalent or slightly more than number of glasses of water it's contained in ocean. Can you imagine how many glasses would you require to empty the ocean? So those many number of glasses is what the number of atoms are there in the small glass. Okay, so that is the size. And now we are saying atom itself is the clean source of sustainable energy. Now when it comes to energy, we have come across energy in different forms, right? Everybody knows that energy cannot be created or destroyed. It can be transferred from one type to or one form to the another, right? Now what are the different kind of energy that you have come across? I will try to keep it interactive more than my slide, because the slides are meant for a particular spectrum, point in spectrum. We'll discuss, it is for everybody. Can you tell me what are the different type of energies that you have come across? Here, what kind of energy you are experiencing? My voice is this. After you go out, there is sunlight, right? And you feel a little bit of heat, right? Wind energy, good. But wind energy, okay, wind energy, what does it actually do? it rotates, right? So it is a kind of mechanical energy that we are talking about, right? धक्का कौन मार रहा है is not the energy, it is the source. But धक्का मारने से क्या हो रहा है ना, गाड़ी आगे जा रही है. ओके अगर पेट्रोल जला रहे हैं हम लोग और गाड़ी आगे जा रही है, what type of energy it is? Yes, अगर कार्बन जला के जो हीट मिल रही है, which what kind of energy? That is also chemical energy only, right? So now you are aware about what are the different types of energy. And first we have discussed that energy can be transferred or transformed or converted from one form to the another, right? Now, are you aware how this electricity, whether electricity is also a type of energy that we are using, right? Everywhere. So nowadays even cars are also running on electricity. Your mobile phone, everything is there which is running on electricity. So everybody knows that electricity is one of the major kind of energy that is the engine of our growth. Now what do you mean by engine of growth? You will understand when you grow up. But at the moment you try to understand that it is very important for us to have energy like electricity. Now how do you generate electricity? Can anyone raise the hand? Yes, please. Dynamo, good, thank you. What is the kind of principle? There is a magnetic field, there is a conductor, and there is a movement, then there is a cutting of magnetic lines and it creates electricity. This is the fundamental idea, right? And then you have to go to Google or some place and see what is Lenz's law, what is Faraday's law, what is induction, right? Those who can understand or have already seen, okay, otherwise others can remember some of these terms and try to put in Google. Now the thing is, we have to rotate a turbine. Have you heard of turbine? What it is? He said dynamo. It is a small turbine, we can say. No, something is rotating and the electricity is getting generated. Now, suppose, have you heard of hydroelectricity? So how is it generating electricity? It is using the force of water from flowing from higher level to lower level, right, which is used to rotate the turbine and you generate electricity. Similarly, James Watt, everybody knows. So steam engine. So he was using the power of steam, right? Now we are also interested in using the power of steam to create or generate electricity. Okay. Now how can we generate lot of steam? This is the question. By boiling water, right? But that is the fundamental thing. Without boiling water, we will not be able to generate steam. So now how to generate steam? धूप में रख दो, कोयले से हीट दे दो, या पेट्रोल से दे दो, गैस से दे दो, या किसी भी चीज से. That means you need a source of heat. Okay? तो अभी हम क्या करते हैं? जब थर्मल बोलते हैं, थर्मल इलेक्ट्रिसिटी, उसका मतलब होता है, क्या होता है? Normally we are using some fossil fuel which you are generating heat, and that heat is used for steam, and then steam is giving you power to roll the turbine, and then you are getting the electricity. Okay. Now today I am coming here from where? Nuclear Power Corporation of India Limited. Now, so obviously the name suggests that nuclear power is we are going to talk about, right? So let us quickly move towards our presentation. So, space. So we have already discussed what is atom. Next. ये 2-3 स्लाइड आगे कर दीजिए, क्योंकि इसमें ओरिजिन है और बच्चे काफी छोटे हैं. Next. One more. Okay. Now let me tell you. See, here it is written 1 kg of coal, right? 1 kg of coal, it will give you 28 megajoules. You forget about, if you know what is joules, it is okay. Otherwise, there is some amount of energy you are getting by burning 1 kg of coal. And if you are having 1 kg of uranium and you have done fission for all those, it will give you 10 power 6, 23 into 10 power 6 kilowatt hour. So you can compare it is 3 million times more for the same mass, right? So in short, we can say that 1 gram of uranium, when it undergoes fission, now we will speak about what is fission. Where from we are getting the energy which is giving us food? Sun, okay? Where from sun is getting all that energy? Fusion, okay? Fusion. What is that fusion? Fusion means two light radionuclide, sorry, not nuclides, two nuclides forming one new nuclides, right? By joining together. Hydrogen becoming helium and so on, right? Now we are going to talk about fission. What, you want to ask something? Please. Did I tell you that we are using uranium? हाँ. Yeah, we can use, but that we have to develop a technology for that. Okay, we'll talk about it if the time permits. I have been given 35 to 40 minutes. Already 7 to 8 minutes have gone. Now, where I was? Okay. Fission. I was telling you about fission. What is fission? When the atom of uranium is split into two parts, okay, it will create new elements, two new elements, and those two new elements will also have lot of kinetic energy. That energy you are getting from the nuclear fission. Now, those who are little elder, I would like to ask you, where from this energy is coming? Have you heard of? Have you heard of E is equal to mc square? Only younger ones are asking. Others are allowed to answer. It is not a children's class. Yes? Yes. Now what is this mass? Which mass it is? Yes? Okay. But that means what she said, I have to tell you in a little different way. It will be simple. What she said is actually okay. Mass of uranium and mass of the product. What are the products? Uranium was the only atom you had, and now you have few atoms, some neutrons, and energy, right? That energy is the difference between the masses of these two things, which is also called as mass defect. And in terms of energy, it is E is equal to mc square. So the difference, that delta M, is what you are getting as a mass. Now why that is coming? It is a little bit slightly higher question. So that we will skip for the day. Now, for the population of 1 crore, we require about 1400 megawatt power plant running continuously for a population of 1 crore. Mumbai, whether it is more than 1 crore or less than 1? More, right? So now let us take this 1400 megawatt. What is the quantum of fuel required? You can see one place we have written per year and one place we have written per day. Okay? 16,000 tons per day, and it is 250 tons of natural uranium per year. Okay? So, which vehicle may be used for this? So many tons of coal? Train, right? And we have to get it from mines, right? Okay? And one more thing. Now, if I burn 1 kg of coal, what is the amount of carbon dioxide that you are expecting to be emitted? More than 1 kg, less than 1 kg, equal to 1 kg? Okay, now whether it is more than 2 kg? Yes, it is more than 2 kg. Why? Because coal is C. What is CO2? So, in addition to the coal which is present, it is adding 2 atoms of oxygen also, right? Right. So we need so much. Now 16,000 tons you have to multiply by say 2. It will become 32,000 tons. You know what is 1 ton? So you are understanding? So per day, now you are going to get 32,000, more than 32,000 tons. This all we are calculating for 1 crore. Okay? What is the population of India? Now you need to multiply that by 140 again. Okay? If the entire energy you are getting from coal, the amount of CO2 that will be liberated will be of that order, right? And everybody knows that once the topic of CO2 comes, what is next? Global warming, right? Global warming, greenhouse effect, all these things are also always under question. Next, please. This is the fission. Next. Now, see, this is about life cycle equivalent emission per unit of electricity by coal. It is 820, around 820 grams. Now, what is this life cycle equivalent? Suppose you want to build a coal power plant. The amount of energy that you generate, electricity, per unit, about 820 grams of CO2 emissions is attributed. Now, whether you know what is the unit of electricity? Have you seen the electricity bills in your house? So, how many units of electricity? Have you seen somewhere it is written kilowatt hour? Anybody seen? What is the unit of power, right? Watt is the unit of power and joule is the unit of energy. Now, when you multiply watt by time, it will become energy, right? Because energy per unit time is power. So, that is why kilowatt hour, 1 kilowatt hour is 1 unit, okay? So, it is 820 for this, then for gas it is around 490, next. For geothermal it will be around 38, all in grams for 1 unit of electricity, next. For hydro, you please don't think that hydro doesn't emit CO2, right? But still I am saying that it is around 24 grams. Why? Because you have to do a lot of construction, you have to do so many activities, industrial activities, steel, everything. So it is all together per unit of electricity that it will generate about 24 grams of CO2. Next. Even this solar also, solar panels and solar cells, everything required associated with it will give you this. Next. This is wind power. It is about 11 and this is nuclear about 12. Next. Now this is the summary. So all these from solar to wind, these are the sources we have to focus on if we want to clean up, right? What are we trying to clean up? Clean up the environment, right? So you know that CO2 is already being used by the plants, okay? But there is only a small amount of CO2 required, not so much that we are liberating due to so many processes. And this is only about electricity generation. There are some places now in villages when you go, people are using wood and burning, even there also CO2 will be burning, isn't it? So that is also there. So those things are not considered here yet. Next. Next. Now we will go through, हम लोग वीडियो बाद में देखते हैं, इसका नेक्स्ट स्लाइड चालू करो. Now this is the simple you can say sketch of a nuclear plant. It is a boiling water reactor, okay? Now you can see on the left side there is a reactor vessel. Everybody can see it is a reactor vessel. Now reactor means where the reaction takes place. Which reaction is taking place here? Which reaction is taking place? Fission reaction, okay? Which reaction is taking? Fission reaction. Which element is undergoing fission? Uranium is undergoing fission, okay? Now uranium is undergoing fission, it is going to generate lot of energy. We spoke about this and we said then it will be heat. How this heat is generated from nuclear energy? Suppose there is one bullet. Somebody is firing a bullet in a metal block. It will stop within few centimeters. And if you touch that metal block, it will be hot or cold? It will be hot. Why? Friction itself, right? So the kinetic energy of that bullet, it will depend if it is slow or fast. If I just throw it with my hand, it will not heat up. But if it is shot from a gun, it will heat. It is not because from gun it is hot, that is why. Okay? Even when you rub your hands, the hands are heated. Okay? So that way, one atom is breaking into two pieces inside the metal, and they are acting like a very tiny micro nano bullets. Those bullets are stopping inside the metal only. That is how the heat is created. And that heat now we are going to utilize for boiling water. Okay? By boiling water we are getting steam, and once we say we have got the steam, you know that we are going to generate electricity. Okay? This is one way. You have heard of Tarapur Atomic Power Station, the first power station in India in 1969. So that is of this type. It is called as boiling water reactor. Here the water is our normal water and the fuel is slightly enriched uranium. Okay? Next. Pressurized water reactor. It also looks almost same, right? Only thing is that the steam is not coming out of the reactor vessel, but it is rotating. Can you see the red color stream? Okay. It is in the closed loop, right? And what is it doing? It is boiling water in the steam generator. As the name suggests, it is generating steam. Okay? This is how. The principle is same. Fission is happening in reactor vessel. It is getting heated, and the water which is there in reactor vessel is now going through a tube to steam generator, and that is boiling, and then that boiled water is giving you steam, and that steam is generating electricity. Next. This is how a single fuel bundle looks like. Okay? This is a uranium fuel bundle. The length of this bundle is 0.5 meter. Okay? And in a reactor where you are going to see the video, one channel will have more than 12 bundles, 12 or 13 bundles, depending on which power it is working. So, and such more than 300 channels will be there. So you can say 12 into 300. That is the minimum number of bundles that will be there in the core or a reactor vessel. In PHWR, that is pressurized heavy water reactor, that core is called as calandria. Okay? And it contains moderator heavy water and coolant also heavy water. Now I need to tell you what is heavy water and light water. Are you aware about this word heavy water? Who can tell? ओनली फर्स्ट लाइन में जो बैठे हैं उनको मालूम है. ओके, कौन बताएगा? बोलो. Is it available in nature? It is. Yes, you are right. You are right in the first side, and I am telling it is available, and it is available in very small quantity, which has to be enriched, and you will get D2O, right? So that is what. Now why we are using this D2O? Because some people will confuse heavy water with hard water. Okay? You have heard about hard water? Hard water is, suppose there is a water somewhere when you go and you are using a soap. There is very little foam or no foam coming out. But when you come to Mumbai, the same amount of soap will give you a lot of foam. Okay? It is because of the dissolved salts in the water which makes it hard. So we are not talking about hard and soft. We are talking about heavy and light. Our normal water, what is the chemical formula of normal water? H2O, right? So how the nucleus of the hydrogen looks like? What it contains? Only one thing. You know what? One proton. Now heavy water will contain one proton and one neutron. Okay? So that is why it is heavy. Okay, so that is heavy water. The property of the heavy water is even light water also moderates. Now how we are going to carry out this chain reaction? Now we spoke about fission. Okay, we spoke about fission. One fission is happening, two pieces of atom have formed and some more neutrons also have formed. Okay, those two neutrons will again rush to another atom to split. Okay, then that will also undergo fission, then one more splitting. So this is the chain which is called as chain reaction, right? So the chain reaction is sustained by neutrons. Okay, you are understanding which neutron? Because along with the two pieces of atom, you are getting some more neutrons. What this uranium will contain? Uranium nucleus will contain 92 protons, right? And 235 minus 92 neutrons. Okay, when they are breaking, some neutrons are set loose and others are getting arranged to become two atoms. So those loose neutrons will again undergo, will give rise to fission. So that is the chain reaction. So for that chain reaction, we need to reduce the speed of neutrons. That is called as moderator. So when you decrease the speed of neutron, it will create a good amount of fission that is required for continuous energy, right? Next. Now this is how the calandria looks like. Now we will start the video. Video is about 8 to 9 minutes. It is a walkthrough to Tarapur Atomic Power Station of PHWR.
Hello viewers. Nuclear Power Corporation of India Limited welcomes you to this virtual tour of a nuclear power plant. Nuclear Power Corporation of India Limited, a public sector enterprise under the administrative control of the Department of Atomic Energy, builds and operates nuclear power plants in India. This three-dimension animation is the simplified replica of a 540 megawatt pressurized heavy water reactor, or PHWR. In this virtual tour, we will take you through various processes of a PHWR. A nuclear power plant houses several buildings and structures, but there are two main buildings in which nuclear power generation takes place. The two dome-shaped structures seen here are the reactor buildings, and the rectangular structures on the side are the turbine buildings. Let us first learn about the reactor building and its systems. The reactor building is a tall and rigid structure with a height of 50 meters and a diameter of 56 meters. A specialty of the reactor is that it is kept at negative pressure than the atmosphere outside to contain radioactivity within the building. This round-shaped building is made of two enveloping walls, known as the inner and outer containment walls. These walls are separated by a gap of 2 meters. Like inside the reactor building, the gap between the two walls is also kept at negative pressure to prevent radioactivity release to the atmosphere. The inner containment wall is made of pre-stressed concrete, while the outer containment is an RCC structure. Both the walls are capped with a reinforced concrete dome. Inside an actual reactor building, there are several intricate systems, equipment, pipes and cables. But this simplified view shows only the most important parts, like the suppression pool, calandria, coolant, moderator, steam generators, reactor shutdown systems and control rods. Let us begin with the suppression pool, which is located at the bottom. It is basically a large reservoir of water used for long-time cooling of the reactor core and used as a supplement to other cooling systems. Above the suppression pool in the center of the building, there is a massive structure called the calandria, which is also the heart of a nuclear power plant. In fact, the nuclear fission, a crucial process in a nuclear power plant, happens inside this horizontal cylindrical vessel. The calandria is made up of a high-grade stainless steel with a diameter of 5.9 meters and a length of 7.8 meters. The stainless steel structures that are connected at either side of the calandria are called end shields. The calandria is filled with heavy water, which acts as a moderator to slow down the neutrons produced in the nuclear fission chain reaction. A set of pipes called coolant channels pass through the calandria and end shield assembly. The metal used for these pipes is an alloy of zirconium and niobium. 392 such coolant pipes exist in a 540 megawatt heavy water reactor. Each coolant assembly, in fact, has two concentric pipes, one inside the other. The outer pipe is called the calandria tube, while the inner pipe is called the coolant tube or pressure tube. For thermal insulation, carbon dioxide is filled between these pipes. The coolant tube has mainly two things inside. One, the heavy water flow that helps to transfer heat to the steam generator. Two, the fuel bundles that generate heat by fission process. Loading new fuel into or removing spent fuel from the reactor is carried out by two fueling machines at both ends of the calandria, which are computer controlled. In Indian PHWRs, the fuel loading is done while the reactor is in operation. This online fueling helps maintain reactivity, power levels, and symmetry. As a result, the coolant also moves through the reactor in both directions. Let us now understand how the fission process takes place in this PHWR. The loaded fuel bundles consist of natural uranium, which is a common element found in the Earth. But how is it used as a fuel? Let's get to know some basics. Natural uranium has two types of atoms or isotopes, namely U-235 and U-238. Among these two, the U-235 is the fissile material. When this fissile material is struck by a slow neutron or a thermal neutron, it will split into two or more fragments. This splitting is accompanied by a tremendous release of energy in the form of heat and two or three fast neutrons. These fast neutrons are thermalized or made to slow down by the moderator in the calandria, so that they have a high probability of hitting other U-235 atoms, thus causing and sustaining a controlled chain reaction that releases more energy and further sets of neutrons and fissions. Thus, in a nuclear reactor, a controlled, self-sustaining nuclear fission chain reaction is achieved. As a result, heat is produced. The flowing heavy water inside the coolant tube transfers this heat to the four vertical cylindrical steam generators that are placed at a higher elevation. Upon receiving the heat, the steam generators, which are filled with flowing light water, raise the steam. The steam raised in the steam generators is taken to the turbine in the adjacent building through the steam pipes. The turbine generator assembly or turbo generator in a 540 megawatt PHWR has one high pressure turbine and two low pressure turbines. The steam raised in the steam generators upon reaching the turbo generator assembly rotates the turbines. The generator, coupled with the turbine, also rotates and generates electricity, which is evacuated through a switchyard and transformer. This nuclear electricity is sent to the electricity grid through high-tension transmission lines, which in turn is distributed to the end users. Back in the calandria, in the reactor building, there are two more important systems: control systems and the reactor shutdown system. The control rods are used to maintain the desired power level of the reactor, while the shutdown system helps to bring the reactor in safe shutdown during normal and emergency operations. There are many other safety systems engineered in the nuclear plant to ensure a very safe operation of the reactor. The entire operation of a nuclear power plant is controlled through qualified, trained and licensed operators. The possibility of human error is minimized by the installation of automated and computerized systems. Viewers, we hope that this 3D animation gives you a greater understanding on how a PHWR functions.
तो अभी आपने क्या देखा? देखा ना सबने कि आंख खुली थी कि बंद हो गई थी? हाँ, थकान के मारे बंद हो गई थी। एक्सेलेंट। हाँ, तो ये देखिए यहाँ पे सबसे वो कैलेंड्रिया जो है ना, उसका एक्चुअल फोटोग्राफ है ये। हाँ, दिस इज द फोटोग्राफ। नेक्स्ट। ये लाइट थोड़ा ज्यादा हो गया। ओके, ठीक है। नेक्स्ट। ये कंट्रोल रूम है जो वहाँ पे आपने देखा था। यहाँ से पूरे रिएक्टर का ऑल द सिस्टम्स ऑफ द रिएक्टर आर ऑपरेटेड फ्रॉम हियर. Many of those systems are actually automatic, but you need to monitor all the parameters and take action if required. Next. You know what is this. Next. Okay. Now I will tell you that India is third largest electrical producer in the world. Okay. The first is China, second. But see here, per capita consumption of India is very less compared to those countries, developed countries. Next. Now here you can see that from 2005 it was 631, now it is 1331. So it is going to increase further. So now the amount of electricity that we required in 2005 and what it is required now is huge. Not only per capita has increased, the population has also increased. Next. Now this is a good picture telling you that what is the amount of energy that a country consumes depicts the advancement in their society and even the life in their society. I am not saying that when you burn more, you earn more. What I am saying is, if you want to do some development and provide basic amenities to everyone, you require some minimum amount of energy, without which it is not possible to be growing. And we are saying that we want to become Vikasit, right? So how to become Vikasit? You definitely have to consume energy, not waste energy, okay? We are speaking about consuming energy where it is required. So you can say, if I am giving you a ticket, flight ticket, and asking you that 1 week you can spend, which countries normally everybody will prefer? Left side ones or right side? See, left side there is Canada, Sweden, US, Australia, and left side it is Ethiopia, Somalia. Where do we like to belong, right? So definitely it is inevitable that we need lot of energy, and at the same time there is a big looming question of greenhouse gases and CO2. So that is what is the catch. Now we have to develop, but we have to develop in a clean manner. So we have already discussed that which are the clean energy sources, right? Next slide. Here it is all over the world, around 60% is generated for thermal, right? And rest is there. Next. Now this is our target. By 2070, India wants to reach carbon neutral, wants to become carbon neutral. You know, is there any country which you know who is carbon neutral? or in fact negative. Somebody told here, now some of you can try. It's our neighbor only, Bhutan, right? So, and you can try to study how they have done that. I'm not asking you to copy that here, but that is one country. Now by 2030, we want 50% of what we need to be installed from non-fossil fuel sources. Okay? At the moment, 70 to 75% is from fossil fuels in India. So we want to cut down to at least 50% by 2030. And which energy we have discussed are clean? Solar, wind, hydro and nuclear. So energy mix of all this together, we are trying to reach to that level. Okay? And why? For getting the temperature to down, slowing down the rise in temperature. Next. Now, if you have some question, you ask, because after this, it is about safety, radiation. I think some of you will be asking the questions from that same zone. So I am stopping here, and you can ask, or should I continue with this for another 5 minutes? See, this is, you would have heard about radiation as he started, that everybody is worried about radiation and what will happen because of, number one, the introduction of nuclear energy. कहाँ से हुआ? हिरोशिमा नागासाकी से हुआ. So the first shot was explosion, nuclear explosion at Hiroshima Nagasaki, which was quite destructive and is there in our mind. And then one more, Chernobyl, right? So now you can see what are the barriers for the radioactivity to come out, which were not there in the Chernobyl, actually speaking. Chernobyl was a poorly designed and very poorly operated. In fact, if they would have just kept little care, this thing they could not have achieved. But they have done all those things which are not required to be done, in fact are asked to avoid. So here, so the entire radiation is there in the fuel bundle, right? That is at number 1, right? And that radiation, it is having fuel cladding. That is the first barrier. Then there is a PHT system, that is primary heat transport system or the coolant tube. After that, there is after that also there is one Calendria tube which is not written there because it is a part of the same assembly. Then primary containment, secondary containment, and then exclusion zone. Exclusion zone is the boundary till which point there is no population staying. Okay? So these are the barriers. Next. Now these are the places where our nuclear reactors are. Next. Now you will see some, these are the actual photographs of how it looks like. These are under construction. Now this is to show that how clean and green the nuclear plants will be, because there is no emission, and that 1.6 kilometers of that exclusion zone, people are doing bird marathon kind of thing, like there is accounting of how many birds, new species have come, what biodiversity is on the rise. Next. So this is about fish and everything. The water which is used is absolutely clean. Next. Now this is about the radioactive waste. Everybody will talk about radioactive waste, those who are aware about it. So even if you are not aware, let me tell you that radioactivity waste is one issue. Now in that, why that is issue is because in United States or some of the countries, reprocessing of the fuel is not considered at all. They consider that whatever fuel is coming out of nuclear reactor is a waste and that needs to be disposed straight away. Whereas in India, we are having closed cycle fuel program. That is, once the fuel is taken out of reactor, it is cooled underwater for definite amount of time. After that, it is reprocessed, and on that reprocessing, from this fuel, you get plutonium-239. That plutonium-239 is also a nuclear fuel. And this nuclear fuel is going to be used in the next stage of nuclear power program. And that first reactor of that nuclear power program, if you have heard, that Narendra Modi went to Madras and he has inaugurated one core loading at MAP at Madras. It is called as Bhavini. It is a breeder reactor. That reactor, you are going to use uranium and plutonium as fuel and thorium as a blanket. Now that thorium again in turn will be converted into U-233. And this reactor is not only generating uranium-233, it is also going to generate 500 megawatt of power. So power continues. In first phase, at the moment, we have got 8,200 megawatts of installed capacity. And that is first stage. Second stage will start from Bhavini, where the fuel which is taken out of the reactor in the first stage will be converted into the fuel which is required to the second stage. And there, the fuel will be converted for the third stage. Why this third stage? Because thorium is abundant in nature. And if you are having a program where the fuel is thorium based, you will almost have infinite power. And that infinite power, I'm not saying absolutely infinite power. That infinite power is till we get to fusion power. For those who already know or may not know, there is one project already going on where more than 30 to 40 countries together are running one project of thermonuclear experimental reactor in France. So once we are getting to that, so we will say that we have arrived at the cleanest possible energy, and then we can go ahead of that. But till that time, this is what we have planned for the energy mix and as well as clean energy mix. And this is the amount of waste that is generated if one family of 4 or 5 is using electricity generated from nuclear power plant for 25 years. If I have to show you what is the amount of waste it will generate from coal, the family has to stay out of house. Okay, next. Now these are the limits which are given. So life-threatening, if Eiffel Tower is the height of life-threatening dose, the dose limit for the public is of the order of brick. And even the dose limit of brick is not reached. Next. So in the end, I will say this is the actual photograph of Kaiga Atomic Power Station near Karwar, which is around 90 to 100 kilometers from Goa. Now you can see that how it looks like. Okay, so thank you very much, and your questions are welcome. Parents can ask, and it is not offensive to ask questions. How many minutes I have? चेरनोबिल में क्या हुआ था ये बताने के लिए पूरी सीरीज बनी हुई है वैसे, तो इसलिए क्या हुआ था ये पूछना थोड़ा सा लंबा हो जाएगा, इतना मुझे टाइम अलाउ नहीं करेंगे ये लोग. बट स्टिल आई कैन टेल यू दैट कोई भी रिएक्टर होता है, आई विल टेल यू जनरल आंसर ऑल्सो, दैट कोई भी रिएक्टर में जब फ्यूल का कूलिंग अगर बराबर नहीं होता है तो उसका फ्यूल शीथ जो है वो डैमेज होता है. उसके बाद उसके अंदर से न्यूक्लियर जो मटेरियल होता है वो बाहर आता है. और जब उसमें ग्रेफाइट यूज किया था एज अ मॉडरेटर तो वहाँ पे फायर हुआ था, और उसके साथ साथ जो ब्लास्ट हुआ, वो ब्लास्ट होने के टाइम पे वो जो पूरा फ्यूल बंडल और ये जो है ना वो बाहर निकल के आ गया. अब ये बाहर क्यों आया? क्योंकि वहाँ पे प्राइमरी एंड सेकेंडरी कंटेनमेंट ऐसा कोई बिजनेस नहीं है. इट वॉज अ काइंड ऑफ इंडस्ट्रियल बिल्डिंग. And if I tell you how many violations they have done, because if it was I think on 26th April, and that 1st May was their like Independence Day, that in Russia 1st May is a very important day. They wanted to declare one result of the experiment which they were carrying out in that Chernobyl, and they crossed all the safety boundaries. What is not allowed to be done, they have done everything. They tried everything that reactor should not remain safe. This is what I can tell you in short. Otherwise, there will be one lecture of 1 hour for that. And it is quite interesting.
In the end of that series you were talking about, it was shown that in around Chernobyl power plant, all of the greenery had grown around it after a
Yes.
lot of years.
Yes, yes. So, then what? So you mean to say that whatever greenery is there is because of radiation in our nuclear
No,
power plant?
no, I
So
was saying
exactly what
that.
you want to ask.
No, I was saying that after some years they were so developed that they even grew some greenery around that power plant, because I think, I don't remember it clearly, but I think that the all of the radiation had gone.
You can sit down. One thing which he said, no, that they developed so much. Actually, if we are not developing, there will be a lot of greenery. Elder ones should understand that the greenery is eradicated when we grow. This is what we have shown to the nature. So what she is saying is actually it is abundant. So there is no one there, so it will grow automatically. It has got nothing to do with what along with radiation also plants can grow, and without radiation also plant can grow. Now there is a natural radiation. You know what? All over wherever we are sitting, we are always exposed to the natural radiation. The sources are different. Like if you are here in the particular hall, in this hall, these walls are also having lot of cement concrete. It will also contain thorium. It will also contain uranium. It will have the daughter products, radon and thoron daughter products, which are continuously going inside our lungs and exposing us. When we are eating banana, fruits or anything, it also contains so many radionuclides that we are going to get exposed. If you are going out and taking a flight, or even otherwise, solar and cosmic radiation is always exposing us. If you dig deep down, you will be exposed with something else. So there is no go where the radiation is not there. It is omnipresent. If at all nobody, if you want to know what is omnipresent, it is radiation. You go wherever it is there. Like Bhakt says, no, that God is everywhere, omnipresent. He is everywhere. There is no place where he is not there. So this is what I am saying. Even if you go down deep 10 kilometers below, or if you go in outer space, radiation is there. So that natural, we are living with the natural radiation. Around 240 millirem is the dose which an average Indian is receiving. And this the limit of the dose which is given by Atomic Energy Regulatory Board for addition into that radiation is about 100 millirem. And what is actually happening is less than 1 to 4 millirem. So that is what is the safety margin which is there. Okay. Now there is one more lecture about this radiation, the constant companion of life. So it will take another 1 hour. Next. Because there is minimum human interference to cut down the trees and disturb the flora and fauna.
You said that the nuclear waste is cooled and then it's reused to make more energy using water. In that process, is water contaminated?
Using water means it is used for cooling. Water is used as a coolant. Okay. Now, don't you know that we are using water for several purposes and water is getting contaminated? There are two processes in which it is automatically cleaned, right? So, there are different processes through which once you pass the water is as clean as earlier. Okay? So, if you are a chemistry student, you can go and find out how the water is cleaned, how the dissolved impurities are removed. Okay? That you can think. There are two parts. Used uranium is not to be disposed. It is reprocessed. What happens is, this is a natural uranium where the content is 0.7% of U-235 and 99.3% of U-238. Now, once it is used, that U-235 from 0.7 it will become around 0.3, 0.2, 0.3. And U-238, since it was there in the reactor, it has got lot of neutron irradiation. It has got some of it has got converted into plutonium-239. Now, once this fuel is reprocessed, you extract the whole uranium Uranium has got many other applications also. Uranium is not so much radioactive. When the new fuel is coming, we can hold in hand, not can we have. The thing is, when it is out of reactor, it is highly radioactive. Once you again reprocess it, you can extract uranium, which is quite clean. There is no radiation as much. Okay, and only about few percentage of that needs to be disposed. Now, when people are saying disposed, we are saying managed. How it is managed? They are stored in vitrified containers. What is vitrification? You have seen the paperweight, and in that paperweight there are designs inside, right? So if you are putting that waste in vitrified glass, means in that when the glass is in the liquid phase, you make a glass out of it. So that why it is done is because if you put in water also, it will not leach out. Okay, so that is how it is stored, and the quantity is so low that it can be stored safely. Now whatever is generated is a very low active solid waste. It is stored in the plant, and over a period of time it will decay down, and they are stored in vaults, RCC vaults and tile holes, and it is not deep down, it is about 2 meters level, and that area is excluded for others. And for 40 years of operation also, you don't require like miles of land. You require few hundred meter by few hundred meter where you are storing everything, and monitoring is continuously happening. I need to tell you that there are, say, in our facility in Kakrapar, around 37 bore wells are there. So in that bore wells, that water is sampled and found whether there is any contamination there. So if at all anything is going out, those 37 bore wells will definitely find, because under the ground the water table will be same, right? So there is ample amount of care which is taken, and it is not that we are certifying that we are good. Bhabha Atomic Research Center has got environmental survey laboratory which independently is having a program, and that program they will sample all the matrices like food samples, water samples, and fish and meat and milk, everything, and that is compared with the pre-setup of reactor, which is called as baseline data. Any increase will lead to a shutdown of our reactor. So we have to take care to run the reactor. Yes.
So, radioactive waste is cooled with water. Can it be cooled by anything else also?
It can be cooled by air also. Okay.
By even-
But you need to understand that I think you are stuck with cooled. You know why you have to cool is because the fuel will be so hot that it can reach to a melting point. Okay. The melting point will be of the order of 1000 degrees. Okay. But normal source which is radioactive or a waste is not so hot. The normal, suppose you keep some glass of coffee here, you don't have to make any effort to cool it, right? So it is like that. The waste, that is, it doesn't emit so much of heat that it needs to be cooled. The bundles, after being removed from the reactor, have got tremendous amount of radioactivity which is decaying, and after some time, once it is decaying, it need not be stored underwater. It can be stored in the dry containers, dry canisters also. In US also they are stored after a year or so, they are taken out and stored in a dry canisters.
But sir, then why aren't we using wind? Then if wind can also be used now?
Oh, I think you are talking about how to generate electricity. Okay. I think I will talk to you in person and make you understand, because I think the time is short. And if you are interested, I am willing to explain everything again. Okay. Thank you. Thank you very much.